All right, we're going to talk about actually multiplying matrices now. The process that you're going to use is matching the first matrices row with the different columns of the second matrix in the product. For example, here you can see in a matrix A, we have the first row is A and B, and the first column for B is E and G. So the very first element of the first row is multiplied by the element of the first column, and you can see that is AE. The second part here is the second element, B, is multiplied by the second element of the column in the other matrix, and all those two products that we find, we then add them together. So it's like we're going sideways and down, and we're going to add those things together. Now, for the position of the top right spot here, or the next thing, we're going to use that same first row again, but this time we're going to use the second column. So that's how we get first row, second column of the resulting matrix. It's one of those things, sometimes it's better just to see it with numbers out. If you notice here, they were very careful in this example to make sure that all the elements of X and Y are different. So when I write them out, you can see each product that's happening, and it can tell which position they come from, except for 3. If I had written this problem, those 2 3s would have been different. One of them would have been negative. It kind of annoys me now. All right. So first we check their dimensions. X is a 2 by 2, and Y is a 2 by 2. So their columns and rows match, and you can see why we're checking that now if we have to multiply all the elements by it. And the resulting matrix will also be a 2 by 2. So let's go ahead and write it out. X times Y is 6, negative 10, negative 3, negative 2. And then we have, I use a dot for multiplication here, negative 5, 3, negative 4, 3. So let's break it down piece by piece here. First row, 6 and negative 3. Those are each going to get multiplied. The 6 is going to get multiplied by the negative 5. We're going to add it to the negative 3 times the positive 3. And that is my first element of my resulting matrix. And remember, I said before, it's really important to have a scheme or a way to tell that things are separate from each other. It's going to come in really important in this kind of problem. So now I leave a nice little gap here for my second element of the first row. I'm going to use the first row from matrix X again, 6, but now I'm going to use the column, the second column in the next matrix, negative 4 plus negative 3 times positive 3. And I should have plenty of space here. Now, I've completely done all of the first row through all of the columns. So now I move down to the next row. And this is where being systematic is really important. I'm on the second row, negative 10 times the first element of the first column plus negative 2 times the second element of the first column. Leave myself a gap, negative 10 times negative 4 plus negative 2 times 3. So when you're practicing this here, take a look at what's in each one of these matrices here, and I'm going to color code some stuff here. These 2 3s come from there, and these 2 3s come from this position. You just have to be very systematic and careful with all the values here. But once you go through all of that, then you're really just multiplying and adding together. Negative 30 plus negative 9 is negative 39. Next one in the row, negative 24 plus negative 9 is negative 33. Next row down, positive 50 plus negative 6 is 44. And positive 40 plus negative 6 is 36. So my resulting matrix after the product is that. Negative 39, 44, and negative 33, 36.